Hey guys, welcome back. So in the last video, I showed you guys this 68, 95, 99.7 or 99% rule. It's called an empirical rule. 68%, 95%, 99.7%. And basically what this means is that we expect 68% of our data to fall within one standard deviation from the mean, and 95% to fall within two standard deviations, and 99.7 to fall within three standard deviations of the mean. So now what I'm going to do in this video is show you how to do it with a calculator. So I'm revisiting a problem that I did before. This problem says a 20-ounce bottle of soda has an average of 18.4 ounces. So if you guys recall, that's mu is equal to 18.4. With the standard deviation of 0.3 ounces, so that's sigma of 0.3. Now here I said, what percent of 20-ounce bottles of soda will have more than 18.7 ounces of liquid in it? Let me get rid of this. I left the answer here from the last video, and we said it was approximately 16%. Because we knew that this was 34%, this was 13.5, and so on. So I'm going to show you how to do it in a calculator. So grab your calculator, pause the video, and let's get to it. Okay. First thing I'm going to do is I'm going to press the second button, and then I'm going to hit the VARS button. Second is in blue, and once you hit the second button, it'll have you access anything that's in blue. So you would get distribution. So you press second VARS. Then you go to this guy right here, normal CDF, normal cumulative density function. So you press that. It's going to give you four inputs that it would like. So the lower bound, the upper bound, your mu, and your sigma. We said that mu was 18.4 and the standard deviation was 0.3. So we knew that. Let me get a different color. This and this. Now, we need to fill in these two numbers. So I'm going to go back to this, to the problem. I'm going to show you what I did here. So 18.7 or higher. So here's 18.7 or higher. Now, typically this would go from 18.7 as your lower number, and your upper number is anywhere, like, let's just say 20 to be safe. Like, let's just say that's the highest, right? 20 ounces, we hope the bottle doesn't overfill. But you could put any number after this as your upper, and it would grab all of this area, all of this percentile, all of this probability. So it would get all of this here. Now, you could choose 20, but you could choose something, I would say choose something way higher than 19.3. That way we can make sure that we got all the way to the end. So what I did was, I chose 1,000 as my end. So my lower is 18.7, and remember it's 18.4. One standard deviation, you add 0.3, and it says or more. I picked 1,000. 1,000 is so far out that I'm going to guarantee to get the probability. So this is your lower number, this is your upper number, this is your mu, and this is your sigma. You press paste, and then you press enter again. And once you do that, this normal CDF gives you 0.15, 8655, and we said that it was 16%, but that was an approximation. Now we have a more precise answer. Now, most standardized tests tell you to round to 2 decimal places. So in this, to the percent to the nearest 2 decimal places, or the nearest hundredth. So what I'm going to do first is I'm going to say 15.87%. So I'm going to move it 2 places over to get it into a percentage. And then it looks like this. First, you should move it 2 places over, and then do the rounding. Remember, this is your tenths, this is your hundredths. So 15.87%, which is more accurate than 16%. So once again, you do lower, upper, mu, and there's an arrow here that shows you standard deviation, and then you press enter. Let's try another example. So I left these steps here for you. You press second vars, number 2, normal CDF. You put the lower, upper, mu, sigma, paste, enter, enter again, and then round properly. So guys, pause the video and do it yourself. Okay. The weights of healthy 18-year-olds are normally distributed with a mean of 180 pounds and a standard deviation of 25 pounds. What percent do we expect to weigh below 155? So I went ahead and I put the mu to be 180 and the standard deviation to be 25, and I did this for you guys. I just decided not to go this way because I know that 155 is below 180, but you guys can do whatever you would like with this. So I put that here, and I want below 155. So I want from here all the way down. So what is my lower bound? My lower bound is always, it's going to be this guy down here. Well, I can pick 100, I could pick 95, but I want to make sure that I grab the right number. So I could just put 0. My upper bound, well, where does it stop? What do you want it between? You want it between this number and this number. So my upper is 155, my mu is 180, and my sigma is 25. I left the answer from the last time we did this to be 16%. So you go here, once again, you pick second, then we go to vars for the distribution. We go to number 2, normal CDF. We put in lower to be 0, upper to be 155, 180, and 25. Just one last time I'll say this. You could pick any number as long as it's kind of far away from 105. You could pick 80, 70, 60. You'll get the same exact answer. You press paste, enter, enter, and what do you know? You get 8655, so on percent. You should round. The question pretty much will tell you to round. But do not round until you move it to a percentile, unless they're asking you for probability. Okay, let's try one more. The weight of healthy 18-year-olds are normally distributed with a mean of 180 and a standard deviation of 25. What percent do we expect to be between 155 and 250? I'm sorry, 205. Well, that's this part right here. We know that it's exactly 1 standard deviation away from the mean in both directions. We also know that 1 standard deviation is 68%, but now we're going to be more precise because I'm going to use a calculator. This is my lower. Remember, you got to figure out what it's between. That's my upper. That's my mean, and that's my standard deviation. You're going to press second vars. You're going to get normal CDF. You're going to put lower, upper, mu, standard deviation. You're going to hit enter. You get 0.68268 and so on. So that's going to be 68.27%. And that's pretty much how we use our calculator. Now, some of you might say, well, if we know those numbers, 68%, 95%, why do we need this? Well, all these questions ask you about numbers that fell on these lines. What about numbers that don't fall on the line? For example, a 20-ounce bottle of soda has an average of 18.4 ounces and standard deviation of 0.3 ounces. What percent of the 20-ounce bottles of soda will have more than 18.5 ounces of liquid in it? So I want 18.5. Now think about this. 18.5 does not fall on a line. I'm not allowed to cut this line into pieces and say, oh, I can divide 34% nicely. It doesn't work that way because this gets larger when it gets closer to the mean. So you can't divide it nicely. So the only way I can do this is if I had a graphing calculator. So this is my remember, you should highlight where you want. So you want it from here all the way or more. So what is this number here? 19.7, 20, 25? Well, I love the number 1000. That way I can guarantee this is my lower, this is my upper, my mu, and my sigma. You just plug it in, press paste, and we've never seen this decimal before. And basically, that's why we need to know how to do it in our calculator. So this is going to be 36.94%. In my next video, I'm going to take all the New York State exam questions based on probability and statistics, or I should just say statistics, and do every single problem using our calculator. So I hope you watch the next video, and I hope this video made sense. Please pause, try the problems yourself, get used to knowing how to do it in the calculator, because a lot of these numbers do not fall on the line perfectly. Okay, see you in the next video.